NOAA issued a geomagnetic storm warning this weekend. Their public bulletin was 18 words long. The storm arrived, and it hit harder than the bulletin suggested. Here's what those 18 words didn't cover. On April 16th, NOAA's Space Weather Prediction Center posted this. A G2 moderate geomagnetic storm watch has been issued for April 17 through 18 due to anticipated CHSS effects. That was it. 18 words. No explanation of what CHSS means. No mention of the secondary trigger hiding inside the stream. No reference to the second solar threat already sitting in Earth-facing position. If you read that bulletin and thought it was routine, that was the point of it. It was technically accurate. It was also incomplete in ways that matter. Right now, from Chicago to Toronto to northern England, people woke up to northern lights last night. Power grid operators from Minnesota to Manitoba were watching voltage alerts. Satellite operators were filing corrective orientation maneuvers. NOAA's G2 scale says long-duration storms at this level can cause transformer damage. This storm has been running for over 24 hours, and it's not alone. The tool millions of people use to track when aurora is visible, NOAA's own Aurora Timeline Viewer, is currently offline, unavailable until further notice. While the storm is happening, here's what actually hit Earth, and why the bulletin's language buried it. Let's start with CHSS, those letters at the end of the alert. CHSS stands for Coronal Hole High-Speed Stream. A coronal hole is a gap in the sun's magnetic field. Wind escapes through it like air through a hole in a sail. That wind travels toward Earth at extreme speed. The coronal hole that drove this storm emerged on the sun's northeast face on April 14th. NOAA's GOES-19 satellite captured it covering nearly the entire northeast solar quadrant. That's enormous. It moved into geo-effective position, directly facing Earth, by April 16th. But here's what the bulletin didn't explain. Inside that fast solar wind stream, something travels ahead of it. NOAA calls it a co-rotating interaction region, a CIR. It's the collision zone where fast wind crashes into slower wind in front of it. Think of it like a snowplow in space. The CIR slams into Earth's magnetosphere before the main fast stream even arrives. And here's why that matters, straight from NOAA's own technical documentation. CIR-driven storms, while typically less intense than direct solar blasts, can deposit more total energy into Earth's magnetosphere over a longer interval. Not a quick punch, a sustained squeeze. Hours of pressure instead of minutes. That's why transformer damage appears on the risk chart at G2. Not because the peak is catastrophic, but because the duration compounds the stress. EarthSky confirmed the CIR arrived on April 17th. Solar wind speeds surged past 600 kilometers per second. That's well above the typical 400 kilometer per second baseline. But here's the number that actually drove this storm. And it wasn't the wind speed. It was the BZ. The BZ is the north-south direction of the interplanetary magnetic field. When it points north, it pushes against Earth's magnetic shield. When it points south, it tears it open. At 2:41 a.m. Central Time on April 18th, the BZ swung to negative 14 nanoteslas, strongly southward. That's when the storm climbed from G1 to G2 in under an hour. NOAA's bulletin said CHSS effects. It did not mention BZ, it did not mention the CIR, and it did not mention what was already sitting in Earth-facing position when this whole thing started. So who is feeling this storm right now? Specifically? Aurora was visible last night as far south as Chicago and New York. That's the 45th parallel. That's the visible sign that Earth's magnetosphere opened far enough south to let particles rain in. But aurora is the visible part. Here's what's invisible. The Western Electricity Coordinating Council, the grid operator covering the western United States and Canada, monitors space weather events in real time. G2 conditions trigger voltage alert protocols from Manitoba and Ontario down through Minnesota and the Pacific Northwest. Pilots flying polar routes between Seattle and Tokyo, or between New York and Europe, have specific communication protocols during geomagnetic storms. HF radio, high-frequency radio used for oceanic communication, degrades at higher latitudes during G2 conditions. Airlines shift to satellite communication backup. That is happening right now. For regular people, GPS accuracy degrades, not enough to lose navigation entirely. But precision applications, agricultural equipment, survey tools, shipping logistics, see measurable errors during G2 and above. And for anyone trying to decide whether to step outside tonight to watch aurora, NOAA's Aurora Timeline Viewer, the free public tool that forecasts when and where aurora will appear, is currently offline, unavailable until further notice. NOAA's own website says to refer to the 3-day forecast instead. That's a text-based bulletin. No visualization, no timing tool. If you didn't know that before tonight, now you do. Here's the bigger picture, and why this particular storm is more interesting than its G2 label suggests. CIR-driven storms have a specific historical fingerprint. They're not the ones that make headlines. The March 1989 storm that blacked out all of Quebec, 6 million people, 92 seconds from normal power to total grid failure. That was a CME storm. The May 2024 G4 and G5 events that pushed aurora to the Caribbean, those were CME storms. CIR storms are quieter in the record books, but NOAA's own science documentation says something about them that rarely makes it to public bulletins. CIR storms can sustain elevated geomagnetic pressure for days, not hours. Every additional hour at G2 is another hour of induced currents running through power grid infrastructure, another hour of satellite drag compounding on low Earth orbit objects, another hour of GPS positional errors accumulating. And there is one more variable active right now that the April 16th bulletin made no mention of. Sunspot AR4419, the largest and most magnetically complex active region on the Sun, is currently sitting at the central meridian. That's the direct Earth-facing bullseye. NOAA's SWPC has flagged it as the primary candidate for M-class flare activity over the next 24 to 48 hours. A sunspot firing a significant flare from the central meridian during an active CIR storm is not the same as a sunspot firing a flare under quiet conditions. It launches a CME into a magnetosphere that is already compressed and stressed. NOAA's own geomagnetic storm science page describes this precisely. A storm-time magnetosphere is more vulnerable to additional solar wind pressure. The shield is already working. Add another hit, and the response is amplified. The April 16th watch said nothing about AR4419. It was about the coronal hole stream. Those are two separate NOAA products, two separate bulletins. Most people reading one never see the other. Here's the 48-hour forecast picture from NOAA's Space Weather Prediction Center, as of now. The coronal hole high-speed stream's influence is expected to gradually ease through today and tomorrow, with a return toward quieter solar wind conditions expected by Monday, April 22nd. That's the best case. The current storm fades, AR4419 stays quiet, and the week ahead is calm. But 3 things to watch. First, AR4419's magnetic stability. NOAA's 3-day forecast at swpc.noaa.gov updates every 6 hours. If the M-class flare probability climbs above 50% in the next update, that region is destabilizing. Check it tonight and tomorrow morning. Second, the B's direction. This is the single most important variable right now. If B's turn strongly southward again, below -10 nanoteslas, while the coronal hole stream is still active, storm conditions could re-intensify before tapering off. NOAA's real-time data page tracks BZs by the minute. Third, CME confirmation from April 15th. 2 coronal mass ejections launched from the Sun on April 15th. NOAA and NASA modeling initially assessed them as not Earth-directed. That analysis is ongoing. If secondary modeling shows even a glancing trajectory, arrival time would fall inside the window when the coronal hole stream is still compressing the magnetosphere. A glancing CME into a pre-stressed magnetosphere is how moderate storms escalate rapidly. Worst case, clearly labeled. If AR4419 fires a major CME in the next 24 hours from its current central meridian position, and if it arrives while the coronal hole stream is still active, NOAA's own storm progression models make G3 to G4 conditions possible. G4 brings widespread voltage control problems on the power grid, GPS degraded for hours, aurora as far south as Alabama and Northern California. That's the ceiling if conditions stack. It requires multiple things to go wrong at once. But every piece is active right now. 3 things to take from this video. 1. NOAA's storm bulletin was accurate, but 18 words stripped out everything that explains why this one is worth paying attention to beyond the label. 2. The CIR inside the coronal hole stream means this storm can sustain pressure for days, not hours, and long-duration G2 events carry risks that peak-intensity G2 events don't. 3. AR4419, the Sun's largest active sunspot right now, is sitting directly Earth-facing at the same time, and those two NOAA bulletins never appeared in the same headline. If you want to stay ahead of what's actually developing in space weather, not just the label but the mechanism, subscribe. I cover every event where the details matter more than the number. Coming next, AR 4419 is at dead center on the sun right now, and the historical pattern of what happens to sunspots in this phase of the solar cycle is something most channels haven't touched yet. That video is on screen right now. Stay safe.